A very good day to all participants and welcome to today's webinar, co-organized by SWA and the Nora Water Technologies. Before we get started, I'd like to take a moment to go over on the following. Housekeeping. To ensure a smooth session, please mute your microphone and turn off the camera. You may communicate with us after the event. Please share your questions in the chat, where we will try to provide answers where possible in the Q&A segment. Do identify yourself so we can respond to any unanswered questions. We will be recording this session and reserve the right to the video. Please complete a post-event survey, which upon return will forward the recording and presentation deck to the respondents. Disclaimer. All information shared is for general information only and does not contain or convey any legal advice or administrative assistance. Information shared today is true and accurate as of publication date. SWA and Nora reserve all rights in the provided material. Now, without further ado, I would like to invite Mr. Mawan Nasikolasi. Mr. Mawan is based in Singapore and he is the General Manager for the Asia Regional Hub, Nora Water Technologies. Over to you, Mr. Mawan.
There you go. Thank you. Yeah, I cannot unmute myself. Thank you and very much. And good morning to everyone. I think everyone is in Asia, so good morning or good afternoon if you are in the afternoon there. Thank you very much for hosting this for the Singapore Water Association. Very much thankful for the opportunity to actually share some information with the rest of the group and with all the participants in terms of this very important topic that is gaining more and more interest across the world, actually, not only in Asia. Chlorate is really has a highly oxidized form of chlorine, creates a lot, is a contaminant or a disinfection byproduct when utilized as a disinfectant in water. Nora has been doing a lot of work on this for a number of years now, actually, as you will see later on. And it's still, the chlorate is regulated by the World Health Association and also by the EPA, although the EPA has not come up with final standards yet, or it has standards, but it's trying to make them even more strict. Trying to understand. There is a lot of confusion regarding chlorate, its formation, how does it form, how to treat it, what are the conditions of the chlorate, and many water companies are actually making a lot of tests. Many water utilities are working, trying to understand really the depth of this issue of chlorates. It's definitely a contaminant. It's definitely something that not good for the public, and therefore something that we all, the water industry in general, needs to dig deeper into it. So Nora has been doing a lot of work, as I said, for a number of years towards this. And as you will see in a minute, as Jean-Paul presents the information that we have, you will see the findings that we've done, both as a company that produces disinfection products, especially on-site disinfection products, and chlorine dioxide, which are the two technologies that the product that it produces and used in the water actually form a lot of chlorates. So you will see the work that we've done and the tests that we've done and under what conditions this can be limited or it can be worked around. If there are any questions, like it was said at the beginning, it can be done at the end. But again, I want to thank everyone for participating, and most importantly, thanks the Singapore Water Association for putting this informational webinar together and share this critical and very timely information with the rest of the community. So if there is anything else that the Nora can do, we're at your disposal with regards to information, of course. And I pass it back to you with no further ado so that we can get to the information. You're on mute.
Thank you very much for the welcome address, Mr. Marwan. Now it gives me the pleasure to invite our keynote speaker, Mr. Jean-Paul Monali. Jean-Paul is the Global Electrochlorination Product Technology Manager at Nora Water Technologies. He has been with Nora for 20 years and started when the name was Severn Trent Services. Jean-Paul has educational background in mechanical engineering, and his career with Nora, he accumulated abundant experience in the design and engineering of the new product and improvements of existing products in the various applications related to water treatment, with especially in electrochloration. Okay, over to you, Mr. John.
Hey, thank you, Jazz, for the introduction. Can you hear me pretty well?
Yes, yes. Go ahead, John.
All right, very good. So good morning, everyone, and welcome to our SWA webinar. So today we'll focus on minimizing chlorate in water disinfection with a specific emphasis on on-site hypochlorite generation. It's really a pleasure for me to actually be here with you and to have this talk and to share, like Marwan mentioned, our experience as Nora related to one of the big challenge in water disinfection, which is disinfection by product. And the talk today is really going to be about chlorate. And I will highlight also the safe and economical solution that we have put in place to reduce chlorate in water disinfection. So our agenda today, just to give you an idea of what we'll cover. So I will touch on what are disinfection by product, chlorate in particular. We'll look at the health effect of chlorate on the human body. We'll look at how chlorate is formed. We'll look at the factor influencing the formation of chlorate and the different mitigation approaches that we have put in place or that we suggest to a lot of our clients. And I will present some of the Nora development, like Marwan said, in terms of on-site hypochlorite generation and how we mitigate chlorate formation. And then I'll go into some of the case studies that we have in terms of helping some of our customers provide safe and clean water. So if we can get to the next slide. So in general, one of the main questions that we usually get is, what are disinfection by product? If you can click on it, Jazz, all the way through. So in general, disinfection by product are contaminants that are added to potable water as a result of the disinfection process. So this is when you have a chlorine-based disinfection that reacts with naturally present organic matter. So the particular disinfection by product we'll cover today in specific terms is chlorate, which is an emerging contaminant with global regulation challenges. And like Marwan said, that these challenges are quite impressive, and I'll share some of the issues that we're faced with. So chlorate is an oxidized form of chlorine, which is introduced in our water source as either sodium chlorate, as an industrial contaminant, or as an agriculture pesticide. So it can also be introduced in our drinking water source through electrochlorination or through chlorine used as a disinfection. So if we can go to the next slide. Now, the next question that usually comes in after we understand what a disinfection by-product is, why disinfection by-product, or chlorate in particular, a problem? The main issue with chlorate is the negative health effect, and all of that depends, of course, on the level of exposure. So if we take a look at, for example, infant, the main source of chlorate ingestion is through drinking water, so which represent about 60% of chronic chlorate exposure for infant. So one of the main health effects attributed to chlorate is the interference of chlorate to the thyroid function. And why is that the case? Is because chlorate actually competes against iodine intake and affects the thyroid. So that's a major aspect of chlorate issues in the health of human. So in order to determine or come up with what we call a health reference level for chlorate, which would not result in any type of adverse health effect, most public health and regulation agency, such as the EPA or the World Health Organization, they came up with what it's called a chronic reference dose. So this chronic reference dose is the amount of chlorate that a human can actually consume without affecting our health. And that number is about 30 grams per kilogram of body weight per day. So that's what they use in their calculation, whether it's the World Health Organization or the EPA or several other agencies. That's the number that they came up with to calculate this health reference level, which we'll kind of touch on in the next slide. So to really understand this, currently, there are limited regulation for chlorate level in drinking water. And several countries, as well as public health agencies, as well as even some companies, as Marwan mentioned, have proposed and published levels which tend to vary. So if we go from one country to the next, those numbers actually might vary. But the World Health Organization, to kind of understand a little bit of the magnitude of this regulation challenge, in 2017, they ran a survey. So about 104 countries participated in this survey. And the conclusion of it was actually quite impressive, is that out of the 104 countries that participated, only about 16 countries had regulated value. And out of the 16 countries with regulated values, 3 of them have regulated value above the World Health Organization, which is about 700 microgram per liter of chlorate in the finished water. 10 out of the 16 countries have their level at the same level as the World Health Organization, and about 3 out of the 16 had levels below the guideline of the WHO. So if you take a look at it, it's actually a range, quite a wide range. So it goes from a minimum of about 15 microgram per liter all the way to 1,000 microgram per liter. This is just to give you a magnitude of the differences in views of approaches globally in terms of setting some kind of standard or setting some kind of guideline. If we go to the next slide, you'll see in more specific term, some of the differences depending on the different countries. So for example, the EPA has a value, a health reference level of about 210 microgram per liter, which is not an enforceable regulation. And it's actually much less than the WHO. And one of the key challenge for public health agency in trying to regulate chlorate is finding this, what I would call this cost-benefit balance between the cost associated with reducing chlorate in water disinfection versus the impact on actual public health if chlorine is not used as a disinfection method for drinking water. So I have to also highlight that chlorate is also being evaluated for regulation in food processing application in Asia and in the European nation. And you also have major water authorities carefully looking at specific chlorate level requirement for their specific application. And on the next slide, you can actually see that many Southeast Asia countries are following the WHO guideline, and they're taking it as a reference. But there's also now some kind of guideline that certain company and certain agencies are looking for when it comes to on-site hypochlorite generation, especially during the electrolysis process. And I will touch on the electrolysis process a little bit later to give you kind of an idea of what I'm talking about here. But some of these numbers that have been looked at, for example, about 30 microgram per liter of chlorine produced for chlorate. So it's 30 microgram of chlorate per milligram of chlorine produced. So this is out of the electrolysis process, out of any on-site hypochlorite generation. And look at China. The existing China drinking water quality standard regulates chlorate at, Jazz, if you can actually switch to the next slide, that'll kind of, yes, perfect. So if you look at China, for example, follows the WHO guideline in terms of chlorate, but in terms of chlorine dioxide, so which is about 700 microgram per liter. And very soon they will come up with a new standard when it comes to sodium hypochlorite generation. And this standard for chlorate coming out of a sodium hypochlorite generation system will be issued probably in 2022. We can go to the next slide, Jazz. So now let's take a look at the mechanism which leads to chlorate formation, especially for 3 chlorine-based chemical. And I'm just going to focus on those 3 here. And as we progress through the presentation, I'm really going to focus specifically on the on-site hypochlorite generation. But the first one is chlorine gas. Chlorine gas does not typically produce chlorate when injected in water for disinfection. So if chlorate is found in water plants using chlorine gas, there is a good chance, a good probability that chlorate came from runoff from industrial sources or from agriculture sodium chlorate sources. So that's for chlorine gas. Now, for bulk sodium hypochlorite or commercial hypochlorite, the primary mechanism of chlorate formation is the decomposition of hypochlorite ion to chlorate. So at certain pH value, where you actually find both chlorine species, which are hypochlorous acid and hypochlorite ion, when they're present, they will eventually decompose to form chlorate. So that's for bulk hypochlorite. In terms of on-site hypochlorite generation, it's similar, except that for when you actually get to an alkaline solution, you have a certain 2 reaction. You have the direct oxidation of chloride at the anode of the electrolyzer, and that actually oxidized to chlorate. And then you have a chemical conversion of hypochlorite ion to chlorate. And in more acidic type solution, when again you have both hypochlorous acid and hypochlorite ions, which are present, you have electrochemical oxidation of hypochlorite ions and hypochlorous acid that leads to chlorate as shown in the slide. Let's go to the next slide, Jazz. So one of the key things to understand is, and this is one aspect of dealing with chlorate that has been talked about a lot. A lot of data has been shared. So one of the key things is that we understand what are some of the major factors that influence the formation of chlorate. So the objective is really, what do you do when you have some of these influencing factors? And this is what this slide actually will share. So if you take a look at the first this first slide, which actually deals specifically with bulk hypochlorite or commercial sodium hypochlorite, one of the influencing factor, the first one, which is quite important, is storage time. So what can be done in terms of storage time to reduce the chlorate level? It's simply to really reduce the storage time. And our recommendation is about 1 to 2 days of storage. The challenge with 1 to 2 days of storage regarding bulk hypochlorite is that it's not sufficient typically, because that sodium hypochlorite has to be delivered on a regular basis then in that case. So that's a challenge with sodium hypochlorite when it comes to storage. The second influencing factor is storage temperature. So the higher the storage temperature, the more chlorate will be formed. So the best way to approach this is to store your sodium chloride in indoor condition versus outdoor. And actually, there's another way of doing it also, is to chill the hypo solution delivered. The challenge with chilling the hypo solution delivered is not only the cost associated with it, but also it just takes time to actually get to that temperature that you're looking for. The third aspect is concentration. Bulk hypochlorite is typically deliver a really high concentration, 12 to 15% or so. So, and we know for a fact that the higher the concentration, the more chlorate will be formed by way of concentration degradation. So the best approach is lower the concentration at delivery by diluting your sodium, your 15% sodium hypochlorite, and making sure that the solution delivery is actually fresh. And this is one of the challenge of delivered bulk hypo, is that sometimes it gets delivered at a lower concentration than what was purchased originally. And then finally, the fourth factor are impurities. And these are impurities in the hypo solution during the manufacturing process. And we're talking about heavy metals such as copper and nickel. If you can limit those catalysts, that will reduce the formation of chlorate. If we can go to the next slide, so we can talk about now sodium hypochlorite from on-site generation. Now, in this case, for sodium hypochlorite made on demand and on site, we come to the same type of factor that influence bulk hypochlorite will influence on-site hypochlorite generation. But I want to highlight one and guide your attention to one key aspect or one influencing factor, which is the production and storage temperature. Now, mitigation approach we have found is to chill the water used before the electrolysis process actually starts. And this is, from our point of view, the most economical way of lowering the chlorate formation. And as we go through the slide, I will actually kind of share what I mean by chilling this water before the electrolysis process actually takes place. So chilling the water will also reduce the concentration degradation rate, even though we know from experience that with low concentration sodium hypochlorite, which actually degrades very slowly, that's not a real challenge. The other factor influencing is pH. But in case of sodium hypochlorite produced on site, the pH is typically at 9 to 9.5, and we know at 9 to 9.5 pH, the chlorate formation is not as substantial as it is at about 7.2 or so. So that's not typically one of the key aspects that drives the chlorate increase during the process of electrochlorination. And then finally, the impurities. As I mentioned earlier regarding bulk hypochlorite, the impurities when it comes to on-site hypochlorite generation are also an issue. The question is, how do we reduce heavy metals from the source of salt and the source of water coming into an electrolytic cell to produce sodium hypochlorite? So these are the influencing factors and how to mitigate some of these influencing factors to lower your chlorate formation. If we can go to the next slide, just wanted to highlight the fact that if chlorate formation is of a concern in your potable water and food processing application, and you are actually currently using a chlorine-based agent for disinfection, I would highly recommend you take a strong look at on-site hypochlorite generation. And on the next slide, I'd like to share, for example, a brief overview of how high sodium hypochlorite is generated on-site and on demand, so you have a fresh solution at all time. If you can click through the whole slide, Jazz, that will help highlight some of the key point of the process. So when it comes to on-site hypochlorite generation, and this is kind of a quick view of it, the process is based on electrolysis of a diluted brine solution. And this diluted brine solution goes into an electrolyte cell. And there are three common consumables: salt, water, and electricity. So you take softened water, which is used to prepare a fully saturated brine solution. That fully saturated brine solution is then diluted with softened water, and the diluted brine solution flows through an electrolyzer where an electrical current is applied to start a chemical reaction, and then the production of a low concentration of sodium hypochlorite. In this case, in most cases, it's about 0.8% solution. So this solution is then considered a non-hazardous because of the low concentration, and it is stored in a storage tank before it is injected into a water pipe or a reservoir for disinfection. So this whole process that you see on your screen is really a fully automatic process, and a process that gives you sodium hypochlorite or chlorine equivalent on demand and fresh for disinfection. So the main question to address now is, what are the economical design approach to help mitigate chlorate formation with such a technology, which is what we'll cover on the next slide. So if you can move to the next slide, Jazz. Very good, very good. So as Maren mentioned earlier, we have done a lot of research when it comes to chlorate challenges for many years. And the objective has always been to develop and implement technology to control and minimize chlorate formation. So we've done a lot of work with electrolyzer cell design and construction. We've done a lot of work and research in dimensionally stable anode coating formulation to help lower the chlorate formation. We even looked at current density, flow rate adjustments, salinity adjustments in the electrolyzer, and as I mentioned earlier, temperature control, which is actually key, and we will see that on the next slide. And also process efficiency increase in order to reduce the reaction leading to chlorate formation, because we know there's a lot of competing reaction happening within the electrolyzer, and while the electrolysis process is ongoing, that favor a lot of the chlorate formation. So if we go to the next slide we kind of highlight one of the patents that we currently have, which is called the split flow. And the split flow is really a way to control the formation of chlorate, as I mentioned earlier, pre-chlorate formation, which is the most economical way of looking at it versus post-chlorate formation. So pre-chlorate formation is as we supply water and brine solution into the process, how can we lower the temperature and how can we increase the efficiency of the electrolyzer to lower the chlorate formation? So this is this patent. This is actually what this patent does, is increase efficiency, control the actually brine concentration through the electrolyzer, and lower the temperature of the solution in the electrolyzer. But at the same time, as I mentioned earlier on the previous slide, in terms of mitigation approaches, we'll also look at making sure that the salt that's provided and the water quality follow certain guidelines to limit the amount of heavy metals in the water or in the solution before the electrolysis process actually starts. Let's go to the next slide, Jazz. So part of the work that we've done, I wanted to highlight your attention to the left-hand side, which is kind of a graph representing some of the guidelines, the world guidelines in terms of chlorate in finished water. And as you can see, the WHO is at about 700 microgram per liter, while the EPA is about 710 microgram per liter. So we've done a lot of testing, a lot of research in this area. And the bottom graph really gives you kind of a perspective or a view of where we are with electrolysis and how we've been able to control some of the formation of chlorate. And if you focus your attention on the right-hand side, you'll see that depending on the dosage rate of chlorine into your into your water source for disinfection purpose, and in this case, we're looking at, let's say, 2 milligrams per liter dose or 5 milligrams per liter dose, you can reach levels of chlorate down to about 8 microgram per liter, which is extremely low compared to some of the reference, for example, the EPA. So we're able, using some of the mitigation factor or approaches that I mentioned earlier, to control the chlorate down to some levels that actually meet some of the either soft drink industry standard or baby food industry standard. We've also done some research in a plant in Suzhou in China. We've done a lot of tests there also, and some of the results have shown, using some of the Chlortec product line that the Nora carries, that we're able to meet the WHO guideline or below the guideline. And the tests were actually conducted at about 3 ppm dosage of chlorine into the finished water. So a lot of tests have been done, and the results are quite impressive and quite promising in terms of how to control chlorate from the electrolysis process. Let's go to the next slide, Jazz. So here's an example. Here's an example of chlorate control in the beverage industry. This one is a soft drink producer in France that approached us with their challenge. And their challenge was to make sure that chlorate level in the processed water used to produce soft drink actually met a strict chlorate level requirement. And in this case, the level is about below 20 microgram per milligram of chlorine. Now, in this case, what they wanted to do is really look at the chlorate formation or the chlorate level coming straight out of the electrolysis process, not at the point of disinfection, but at the point where the chlorine is produced from an electrolyzer. So 20 microgram per liter is way below even the EPA standard. So we designed an on-site hypochlorite generation for this company that you see on the screen on the left-hand side. And here what we did is that we chilled the water, as I mentioned earlier, used for the electrolysis process. And we reduced the hypo storage capacity to about 1 day storage. no more than 1 day storage. So this gave them the opportunity to produce their sodium hypochlorite on site and dose that sodium hypochlorite fresh as soon as it is produced. So this is one of the main recommendations that we have, is to make sure that temperature is actually taken into consideration, storage is taken into consideration, but also you can take different applications and combine different method of mitigating chlorate formation into that same process in order to lower that chlorate formation down to some very low numbers. So in the case of this manufacturer of soft drinks, they give us a strict chlorate level requirement, and we actually met that chlorate requirement. Let's go to the next slide, Jazz. Here's an example of a municipal drinking water plant in China. This is a plant called Taizhou. I hope I'm saying the name correctly, water plant. So this plant was originally using chlorine gas for disinfection, but the plant was ready to kind of expand because of growing population needs and also concern in terms of safety. So they decided to replace their chlorine gas installation with an on-site hypochlorite generation system, which was produced by Nora. And Nora provided this equipment with a China domestic drinking water certificate. And this is an important certificate in China when it comes to on-site hypochlorite generation. And all the Chlortech system produced by Nora have this certificate to offer for the Chinese market. So the new system eliminates site safety concerns. It provides a reliable disinfection to meet the new expansion that was required, and also ensure that they have water quality with low chlorate level standard. The next slide will also kind of share with you some of our experience in terms of electrochlorination, but also on-site hypochlorite generation. And it spans, if you go to the next slide, Jazz. Yeah, perfect. So this is just all of these case studies really span across the globe in terms of what our experience is in terms of electrochlorination and specifically on-site hypochlorite generation in various geographical regions. So any type of solution that you're looking for, please don't hesitate to contact us, and we'll be able to kind of address some of these concerns and how to address some of these concerns. In the next slide, Jazz. Here's another example of two of our on-site hypochlorite generation system in China. One is on the left-hand side. This is in Chongli water plant in Chongli, China. I hope I'm saying it correctly. But this is the city which was appointed as one of the places for the 2022 Winter Olympic Games, and the government here wanted to upgrade their disinfection technology to something much safer and more reliable solution to meet the local water quality standards. So they selected Nora. In this case, it's the Nora Myox brand. And this system that you see on the left-hand side produces about 2 kilograms per hour of chlorine equivalent. And this system was installed and commissioned last year, and officially it will be put to use actually sometime this year. The second side that you see on the right-hand side, this is the Nanjing water plant in Tibet, Lhasa. This is a water plant with the highest elevation in the world. So that presents itself some major challenges. Simply, one of the big challenges is just getting even transport of liquid chlorine cylinders or even chlorine bleach to the site location. So the challenge with this plant is difficult and long distance transportation, but also unsafe for site operate to handle hazardous chemical such as gas chlorine or or even bulk hypochlorite in some cases. So in this case, we helped the Nanjing plant install 4 on-site hypochlorite generator. These generators produce about 17 kilogram per hour of chlorine, and this is each unit producing about 17 kilogram per hour. On the next line, Jazz. This is an example of a drinking water disinfection plant in Signal Butte, which is located in Arizona. In this case, this plant produces about 34 kilogram of chlorine per hour. This is a large amount of chlorine produced in a single hour. Since this is a drinking water disinfection plant, chlorate will eventually become an important concern, especially if it gets regulated at some point. So it's very simple with such installation to use some of the mitigation approaches that I've mentioned earlier to lower the chlorate formation and meet EPA standard, at least the EPA standard that is currently set at about 210 microgram per liter. On the next slide, it's another example of another installation. This is an installation of one of our brand called Myox, which is also an on-site hypochlorite generation system. And this one was installed in Laguna Beach, California. So this water plant supplies drinking water to an exclusive beach community in California. And it produces about 2.8 kilogram per hour of chlorine. Again, since this is a drinking water disinfection plant, chlorate will eventually become an important concern, especially if it gets regulated. And again, it's just a question of applying some of the mitigation approaches or method that I described earlier to try to lower the chlorate formation. On the next slide, this is another water plant in Prestonsburg City Utility in Kentucky. It produces about 22.7 kilogram per hour. This is also a pre-treatment and final disinfection for drinking water. So the reason why I wanted to share with you a lot of this case study is really to express the fact that with on-site sodium hypochlorite, there is a way to mitigate chlorate formation. So we know that with electrolysis, with bulk sodium hypochlorite, you will produce chlorate. Now the question is always, how do you reduce that chlorate so it doesn't end up in the finished water, which will be consumed by all of us, and potentially have some health effects. So this is what we've been able to accomplish, is to be able to control those chlorate levels and meet the standard across the globe. And we know that these standards are changing, and they're changing on a regular basis. So we're staying ahead of a lot of some of these standard changes to make sure that when there becomes regulation, we're actually able to meet some of these regulations. If we go to the next slide, Jazz. So to summarize, really, what the Nora on-site hypochlorite generation is that we can provide a safe, efficient, low life cycle cost, reliable, and the key things here is on-demand sodium hypochlorite. We're able to byproducts, especially chlorate. We have experience with tons of installation across the globe, and about 97 years of experience in terms of electrode manufacturing and DSA technology. And based on that technology and that experience and all the research we've done, we've been able to optimize really the process itself to the point where we're able to save a lot of our clients about 15% in terms of operating cost when it comes to lower salt consumption. And we have a range of product that can cover any type of application that can be required in the market. In the next slide, Jazz, I wanted to highlight to all the participants, if we can go to the next slide, is really that we're not limited to electrochlorination. Jazz, if you can switch to the next slide. I guess there's a little bit of a delay.
Is this the one or?
Yeah, this is the one. This is perfect.
Oh,
this
okay,
is
this one. Okay, all right.
Yeah, this is perfect. So a brine of electrochlorination are not limited to brine electrochlorination in terms of Chlortec, Miox, and Cyclo that you see on the screen. But we cover application in onshore and offshore oil and gas and marine market with our seawater electrochlorination brand. And these brands are Cyclor brand, the Sanelec brand, the OmniPure brand, and the Mariner brand. And finally, we also cover ballast water management with our Balpure brand. If we can go to the next slide. So to close, we have global expertise to support any opportunity in the municipal and industrial market. We're a reliable and effective treatment solution. We have staff in strategic offices across Asia and local partner that can support. In addition to electrochlorination, our experience also expand into disinfection and filtration technology. And so we're here to support. So any question that you might have related to on-site hypochlorite generation or chlorate more specifically, and how to address disinfection by product chlorate related, or in some cases bromate and perchlorate, we can help you with some of these questions and how to mitigate some of these issues. So this is the conclusion of my presentation today. And I hope I've been able to share the challenges of disinfection by product, and in particular chlorate, and share some of the economical and effective mitigation method to address this challenge. So I want to thank all of you for your attention and this opportunity to actually present this topic. Back to you, Jazz.
Okay. Thank you. A big thank you to Jean-Paul. Thank you for the knowledge sharing on the insights and the OSCG process, product portfolio introduction, and the case sharing, and how these systems can improve and help to secure our safe water for us. Now we come to the Q&A segment. I got these 3 questions sent to me. Jean-Paul, the first one. The first question is, besides chloride formation, what other factors we need to take into consideration when choosing the different brands of OSHG systems?
Well, one of the key things to look at in the selection of an on-site hypochlorite generation system, putting aside the chlorate aspect of it, is to also focus on the efficiency. And when we talk about efficiency, we're talking about how effectively you're using, which are the main consumable in the process, which are water, electricity, and mainly salt. How do you effectively use those consumable to produce a certain amount of chlorine? So putting aside chlorate, that's the main aspect to consider to lower OPEX, especially for municipalities looking at this type of technology, lowering salt consumption as much as possible for the life of the system installed. So that would be one of the area I would focus on, finding a system that produces a sodium hypochlorite solution at the most economical way possible long term.
Okay, thank you, Jean-Paul. Okay, this is a very short question here from Sabah. It says, how to maintain the pH level at 9?
Well, it depends. For on-site hypochlorite generation, typically we get water from a municipal water source. And through the electrolysis process, the typical pH that you will see in most electrolyzer is around 9 to 9.5. So that's that's the typical pH you will see. So there's nothing to really change in terms of pH control in terms of the solution for on-site hypochlorite generation. So at that pH of 9 to 9.5, we know from research that the chlorate at those levels are not as substantial as it is at, let's say, about 7.2. 7.2 is really the highest amount of chlorate formation. And since on-site hypochlorite is at a much higher pH than metal pH, it's typically not as substantial as it would be at 7.2.
Oh, thank you, John. Okay, we have this question from Green Dex. Slightly long. Okay, for the OSHG system present in WTPS in China, do the water operators have gas feed CI2 stroke bulk sodium hypo system as standby in event of OSHG breakdown?
That would be a question that I would pose to my colleagues in Asia that have a lot more knowledge in terms of that specific plan. I'm not sure if Crystal or some of the Asian partners are actually on the line that can answer that question.
Okay, probably we can also reply to Grindex separately on the email. Okay, there's one question here. Yeah. Okay, from Shankar Babu. He says, how about the analytical methods to monitor the chloride in UG/L ppb level? Is it required online measurements or offline lab-based measurements?
It's typically, from our experience, we haven't done any type of online measurement. It's typically lab type measurement. And one of the key aspects of chlorate measurement when it comes to on-site hypochlorite generation, the challenge is the amount of salt or brine solution or salinity in the solution itself. So the solution has to go through a certain process before it's analyzed for chlorate. Otherwise, when you take the measurement or you're trying to measure for chlorate, you have some amazing spikes due to the salinity of the solution. So typically, from my experience and from all the work that we've done, it's always been sending samples to the lab to be analyzed, but it has to go through a certain process to before the analytical aspect of it is done at the lab.
Okay, thank you, Jean-Paul. There's someone who replied, I think, from Nora from Yutian on the question earlier we mentioned about whether the bulk sodium system is standby in event, and say yes, their bulk hypo system is standby. So that's they've been answered. Okay, we have one last question since to time limit. It says, will chilling the water support for minimizing the natural degradation of 0.8% hydrochloride, HCIO, I believe, during storage?
Sorry, can you repeat that question again? I didn't get the first part of it.
Okay, will chilling the water support for minimizing the natural degradation of 0.8% of HCIO during storage?
Well, this is a tricky question. So as you saw on some of the slides, so chilling the water through the process that we've established, which is that split flow, the pattern that I mentioned earlier, we're doing two things, and I will answer the question of storage shortly. But we're doing two things. One is we increasing the efficiency of the first pass of the process. That's one, which is key in terms of chlorate control and chlorate reduction. And then two, we lowering the temperature during the process itself within the electrolyzer. So we're dropping the temperature to make sure that it stays within a certain range. And we know from experience that there's a certain range of temperature within the electrolyzer that gives us the best possible level chlorine in terms of lowering the number of chlorate in the solution. But then what it does is that when the solution comes out of the electrolyzer, because we chilled pre-chlorate formation or pre-electrolysis, excuse me, when the solution comes out of the electrolyzer, it comes out at a lower temperature or also a lower temperature than it would if the solution of the water was not chilled pre-formation. So that helps also when it comes to storage. So by the time you store your sodium hypochlorite, that sodium hypochlorite is at a slightly high temperature than the starting point, but it's not high enough to create or to form more chlorate within the storage time. And again, I want to highlight this point. If you're looking for really low chlorate levels, it's best to look at several mitigation approaches. So not just temperature control, but it's also storage of your sodium hypochlorite in terms of length of time and location, whether it's indoors or outdoors. So all of those need to be taken into account as a whole if you're looking for specific numbers. So if I'm looking at, let's say, 700 microgram per liter, which is quite a high number, I will look at certain mitigation factor, but if I'm looking at 10 microgram per liter, then I have to actually look at other mitigation factor and put all of them combined to be able to accomplish some of those numbers. I hope that kind of answers the question.
Sure. If any participants have any further questions, do send me an email. And also during the post-survey feedback when I send to you, you can write to me and we can get the Nora team to answer your questions. Okay, we have one final question for this webinar. Okay, it comes from Mr. Emmanuel. He says, when produced on-site chlorine solution is dosed in treated water, will this eventually produce chlorides, right? I mean, question mark, right? And in bracket it says uncontrolled environment, but in this case, it will be lower. I hope that question is clear. Or shall I repeat again, John?
Yeah, please repeat it again.
Okay.
It wasn't clear.
Okay, put a couple of question marks here. When produced on-site chlorine solution is dosed in treated water, will this eventually produce chlorides, comma, right? And bracket says uncontrolled environment, question mark. But in this case, it will be lower, question mark again. If it is it's very unclear what I'm saying, probably what I can do is, Jean-Paul, I can send this question to you.
Yes,
and then
that'll
you
be
can reply
best.
me an email. I can reply to Mr. Emmanuel. Yeah.
That'll be best.
Okay.
But thanks, Emmanuel, for your questions. But we'll get back to you on that one.
Okay. Okay. Thank you again, Mr. Jean-Paul, on answering the questions, and the Nora Technology for co-organizing today's webinar. We'd like to thank all of you participants for joining this webinar today. Please visit our website under the upcoming event section to view our 2021 events and training courses. Finally, to all our Chinese participants, we wish you good health, happy and prosperous Chinese New Year 2021. Thank you, and we'll see you next time. Bye.
Thank you.